So now we're on example 4, text messaging costs, and this involves the sum of random variables. So we're looking here at an expression for x, the random variables for the number of texts per month. And we are given information about the expected number of texts per month. Recall that using a rate, text per month, means that we can start off by making an assumption here that we have a Poisson random variable. X is a Poisson random variable, and recall that the rate lambda is the same as the expected value for x, and that means that we have lambda equals 500. And because for a Poisson variable the expected value is the same as the variance, we also have here that the variance of x is equal to 500 as well. So when we're looking at the monthly charge for texting, the monthly charge for texting will be the standing charge of $10 plus 1 cent times the number of texts that we send. So we're looking here for the expected monthly bill, the variance and standard deviation for the monthly bill. So again, recall here that we're writing x is a Poisson variable with a lambda value of 500. And our total cost is equal to 10 plus the cost per text number 0.01 multiplied by the number of texts sent, x. So we can write down that the expected value for that total cost, the expected value of t, is equal to the expected value of 10 plus 0.01x. And for that we're going to have to use the general expressions for expected value of ax plus b. These are from the formula sheet. The expected value of ax plus b is equal to a times the expected value of x plus b. And the variance, we'll write that one down as well, for ax plus b is equal to a squared times the variance of x. Now these formulas you can take from the formula sheet. We'll write them there for verification here and reference. So here we're going to write the expected value of the total t is equal to 10 plus 0.01 times the expected value of x. And that's making use of that formula there at the top. So that's equal to 10 plus 0.01 times by 500. And that comes out at a total bill of $15. Now we're looking at the variance for t. The variance for t is the same as the variance for 10 plus 0.01x. And that, using the formula at the top, is equal to 0.01 squared times by the variance of x, which means that we can write 0.0001 multiplied by 500, because the variance of x is also the value of lambda, 500. And that gives us 0.05. And so the standard deviation of the total cost is the square root of the variance, which is the square root of 0.05, and that comes out at 0.2236. And of course that standard deviation measure is in the same units as the expected value, so that's also a dollar value. So we have the mean and standard deviation for the total bill.